Another method to compute antiderivatives, to find antiderivatives, is called integration by part. Okay, integration by part. So let's find out how it is. How does it work? Integration by parts. So the method. Let's start by recalling the differentiation of the product of two functions. We know that we established that the derivative of the product g of x, okay, was equal. So it's the derivative. So let's say fx g prime of x plus f prime x g of x. Okay, so since the derivative of the product is this function, so this product is an antiderivative of the other side. Okay, so we can say that then an antiderivative of fx g prime x plus f prime x g of x, antiderivative, okay, is fx plus g of x. Sorry, not plus, product g of x, okay, is not a derivative. Or if we separate, so I can separate, then I can deduce, if I separate these integration, so I can write the following: f integral fx g prime x dx equal fx g of x minus f prime x g of x dx. Okay, and this formula, this is what we call a formula of integration by part. Okay, so we, okay, so this is the formula, integration part formula. Okay, integration by part, integration by parts formula. So practical way to memorize this or to practice it is to introduce the following notation. Usually we set u equal fx, okay, then du will be f prime x dx, v, let's say dv is g prime x dx, then v will be g of x. Okay, and then look what we can write. We can then write, we have then the integral, so fx, so it's u, g prime x dx, g prime x, here g prime x dx is dv, so dv equal u times v minus v du. Okay, so this is the formula, also written differently, and most of the time this one we will use. Okay, here it is. Okay, so this is, it appears like simple idea, but yes, it is simple idea, but with great applications and consequences. Okay, now you will see we will increase the family of integration by part that we know, family of antiderivatives, okay, that we can handle. Okay, an example. So first example, let's say first example here. Okay. Find the following antiderivative. x sine x dx. So you see here we don't see what kind of substitution we can do. So the method of substitution here is not useful. But the idea of integration by parts uses the product of two functions, and if the purpose always to use this manipulation is to bring ourselves to an integration that is simpler, that is feasible, that we know how to do. So this is our purpose. So if I choose here f is x here, then at this side, the second right side, I will get f prime of x. F prime then will be 1, which is interesting. Okay, so let's do that. Let's apply then choose u. So I will choose u, choose set. So set u equal x. Okay, then du will be 1 times dx. dv is sine x dx. Then v will be the derivative. So we'll minus the derivative of cosine is minus sine, with minus will give me sine x. Yes. Okay, so you see now let's yes, we want to find the derivative of this function. So it will be, let's bring ourselves to use the notation. So it's u dv, so it's times uv minus, I prefer to write it each time so that I don't do mistakes. So u times v, I see it's minus x cosine x minus v minus cosine x dv is 1 dx. So now I know how to compute these antiderivatives. So minus x cosine x plus antiderivative of sine is cosine minus cosine. So I will get no, the derivative of sine is cosine. So plus cosine x plus sine x plus a constant. The derivative of sine is plus cosine, which we have here. So you see how it is practical. Let's do another example. Okay, another example. Yes, let's do it just here after this one. And second example. Find this time. Find the derivative of ln x dx. Okay. So here, we don't have the, yes, I will set u equal ln x, so that the derivative gives me 1 over x dx. Then the other dv is the only remaining function I see here as factor is 1. Okay, 1 dx. Therefore, v will be x, not the derivative. And see now, we will have then come back. So ln x dx will be is u uv u dv, yes, u dv equal uv minus v du. So u times v is x ln x minus v is x, du is 1 over x dx. So we will have here 1, and the derivative of 1 is x. So it's x ln x minus x plus a constant. Okay, so here it is. Now, let's know what if I have a finite definite integral. Okay, what if I have so if we reproduce here the steps at this level, if I have to compute definite integral, so I will do the following. I will have to write let's write in blue, or yes, so I will have to write integral, or let's do it from here, e to b of the derivative of fx gx. Okay, that's equal to e to b fx g prime x okay, plus f prime x g of x dx, okay, so dx. So here we use the fundamental theorem, so it will be, let's erase this part, so it will be equal to fx g of x, take it between x to a to x to b, equal to, we can separate now, fx g prime x plus a to b f prime x g of x dx. Again, so we will obtain, if we have definite integrals, we will have fx, we can apply, okay, there is a dx here that I missed, equal, so fx g of x to take between x equal b minus a to b f prime x g of x dx. Okay, and this is, yes, the formula we can use when we have definite integrals. Okay, so an example, an application here. So let's start doing an example here. What about find, compute, or the definite integral arctangent x dx? Okay, so yes, let's proceed. Use u equal or yes, I think here I don't have to write this. Yes, okay. Yeah, so u, I can use u. So I'm thinking if I should write for you the corresponding, yes, but I think it's easy, we can guess it, but anyway, we can do it also. We can do it, why not? So using it as notation, we would have also a to b u dv equal uv with x equal a to x equal b minus a to b of v du. But maybe it's much better to leave it as function in x, better, we say it better. Okay, so still okay. So an example we said, so find the definite integral arc tangent x dx. Okay, so here I choose u arctangent. Okay, so du, so that du is 1 over 1 plus x2 dx. What about dv is 1 dx and v will be x. Now, so let's come back here. So it will be uv to take between 0 and 1 minus 0 to 1 v du. Okay, so yes, continue here. So uv it's x arctangent x from 0 to 1 minus integral 0 to 1, so x over 1 plus x2 dx. And here I see that arctangent at 1, so it will be arctangent at 1, at 0 is 0, minus, here you have ln of 1 plus x2. Here we use substitution, so I did it quickly here. And finally, yes, we deduce the value of our arctangent of 1 is pi over 4, and here we have then minus half of ln 2. So this is the value of my integral. Okay, so this is the method. So you see integration by parts. It's very simple. The idea is very simple, but will allow us to make better, much more calculation. It's much more complex antiderivatives. Okay, compute. So let's do one more, maybe one more yes, one more example. So another example is the following. So find the following antiderivative t square et. So I need to increase the size. Okay, so let's write this one, same size. Okay, so the following example, find the antiderivative of t square et dt. So here again, so the idea is to decrease here the power of t squared. This is the term that is causing problem. So I will make a choice, u equal t squared, then du will be 2t dt, v is et dt, then dv, then v is et. We know the derivative of the exponent is itself. So I can write it's uv. So uv is t square uv minus v du. Okay, so it's uv is t square et minus v integral v et and 2t here dt. So still I have a problem with this one. So I will make another integration by part for this integral. So I'm still using the same notation, but I know what I'm doing. Okay, otherwise if you are worried, so you can take capital, for example. So let's put t, then du, or 2t, then du will be 2, okay, dt. What about dv capital? Let's et dt, then v will be et. And then, so here I can write one more line. So t square et minus, I will say it's uv minus v du, like that, and then replace everything. Look now, we have uv, so 2t et minus integral capital V dv v et 2 and dt. And now I know an antiderivative of this function, so finally I will get minus 2t et minus 2 et plus a constant. So if you take a factor, we have 2t minus 2 plus 2, okay, et and plus a constant. So here is the idea behind. Okay, so you see, sometimes we need to apply it several times. We need between the steps, we need sometimes to use substitution. So to get this idea quickly and can think about it, you need to practice, to get more practice. Okay.